Hello and welcome back to compiler programming. Now that we have our executable mostly sorted out except for the sizing of the sections and few minor calculations, we can start to try to integrate it with the main setup that we have for actually creating executables. And that means it will need to accept some input and do something with that input. So the first thing, I guess, would be to try to make it replicate the existing program. And for that, we'll probably need to change some headers, rearrange some stuff around, and in general prepare our code to be ready for this kind of stuff. Okay. First thing, I guess, would be to start accumulating imports inside of the program so that we can later use them both in the JIT version and inside of this compiled version that we have here. And even for the JIT version, a big change that will have to happen at some point, maybe today, maybe later, is that we should stop encoding functions as soon as we end the function block and instead have like a explicit now compile this program instruction or function call that would do all the calculation, because otherwise we might run into issues with the encoding into an executable file, but we'll see later how it goes. Maybe it'll be fine. For now though, let's take these structs that we defined previously in PE32 file and just bring them over here and figure out how you want to deal with them. First thing is at some point I brought in this array type that allows me to have very simple dynamic arrays, and this is what we will use for these functions here and for the import libraries as well. So the way that works is I need to just add a type def, and then the rest is taken care of by library. I could create very easily array of that type and push it. But there is nothing really fancy there. Like so. And we also need another one for the import library itself. Okay. So I have array import name to RVA and array import libraries. It's just little convention. You can choose to name it whatever you want. And for this stuff, it just means that here I could change this thing to functions and remove the function count. That will mean that I will need to do a bit of refactoring, but this is okay, and we can start with that. The same thing is with program. Now I can just do array import library and say import libraries. Okay, so that now it will blow up very badly, but that's perfectly fine because we can fix it. Okay. Let's figure out what we need to do. First things first, I don't think we will need so much of this stuff anymore because we were just trying around different versions, which will eventually be moved in their own test cases. For now, I will just comment out this stuff and try to replace it with something more generic. And maybe I will right away start wiring this to accept program. So let's just say program star program, and we'll go from there. Okay. We have these import libraries, that will have to slightly change. Let me just verify. How do I get one value from array? Well, it is array get. So this is what we will use. We'll just say program import libraries and array get program import libraries, and I want to get the ith one. Then as far as the size, we also have that. We can say array count. So instead of static array size, now it becomes a dynamic one. And the same thing here. Let's rebuild it, and hopefully these two lines will be fine. In reality, it now complains that it has no idea what the program is, but we can very easily fix that by just adding a value include, and we are back to a bunch of errors. Okay, we'll figure out what all that is in just a second. For now, let's fix the obvious things. So function count does not exist. Instead, it will be array count of lib functions, I guess, something like this. Okay, that works. I'm not very certain why program one didn't work. Import libraries. Yeah, it's called import libraries. Okay, we'll see what they say after I clean up majority of the stuff. Okay, here I will probably get the function out so it is easier to deal with it. And we again do array get lib functions. Instead of this, we just say I. And now I can do function, change this to arrow, and see if we are making progress. It looks like we are. And here, I bet the issue is that this is actually a signed value. Not sure why it is signed. Maybe I should fix that, but for now it's fine. Here we say function name. Good, and the same stuff here, function name. Okay, that even ended up being slightly less messy, which is always good. Okay, that code is basically a copy of this one, more or less, but we have to be careful not to mess stuff up. Okay, this is good. Library, I can also copy this one. I think I can copy like so. No, I have to be careful with this because it does a bit more than the previous one. There is this libdll IAT which we need to take care of, and finally this stuff. This is where we can copy paste. Okay, making some progress. The same situation over here. Maybe we should figure out how to abstract it better, but for now that is fine. And this stuff here as well. And we say function name REA. Okay, looking good over here. And one more time. We go through the libraries. Okay, and one more. And again. Let me copy the other portion so I don't have to type it in. And we have stuff. Okay, now we have an error here because we are not passing a program. Now, later on, we will just use our standard test setup with program coming from here. But right now, I just want to make sure that I didn't make any mistakes in the code I just did. So the best would be to handcraft a program to have exactly the libraries that we want and go from there. So how do we do that? Well, we say program is this stuff, and we only care about imports at the moment. So I would say import libraries, and that is gonna be, I think it's called make array or something. I don't use this stuff too often, so have to look it up. It's called array alloc, and I say type and count. Okay, that's fine. The type of it is array import library, and the count, whatever. Let's say we reserve memory for 16 for now. Okay, and we pass in the pointer to the, okay. We also shouldn't forget to free the memory to be nice. The way we do that is we say array, is it called free or is it called destroy? It's called array free. That's fine. Array free of program import libraries. Okay. We are building, but if we try to run this, it will crash because we are not passing any libraries, but let's observe that happening. Yeah, so we actually caught it ourselves. We didn't even get to run the executable. We realized that there was a reference to exit process function that we didn't know what it was because it wasn't part of this definition. So it's a good thing to have. Okay, well, let's make it part of this definition. How do we do that? Well, the way we do that is we say program import libraries, and we say array push, I think, and then I can do import library, and then we put stuff here. Okay. Now, the tricky part is that we'll need to have another array for our functions. So let's create that. And we say array of import, what is it? Array something something. Import name to array is array alloc of this stuff. Again, let's get 16 of those. And we push there. Let's rearrange stuff a bit. So we first get the name of the functions, and then we get the name of the arrays. Okay. For this one, we want to push one of these, and we are gonna push it into functions, or kernel 32 functions. Okay. Kernel 32 functions, and dot name is exit process, like it was before. And then I think I will use this stuff as well, which will eventually extract into a function. So we'll have something like add import, and we pass in the program, and we pass in the name of the import, and it just pushes one of these, which is going to be pretty handy. For now, this is fine, and we now can use it here, where we say functions is kernel 32 functions. Let's free this array as well to be nice people. Okay, it still builds, but we need to add more information here. So there is this DLL stuff, which is a copy of this, and we might need a bit more things as well. So this one we'll call kernel 32 DLL, and here what do I need to do more? There is image thunk RV, which needs to go into here as well. Okay. So now we have a better structure and we are ready to try this out. Let's run the tests and see if I have messed up somewhere. I did not. And now we have a very nice preparation for being able to do this more generally, not just in this test. For now though, let's save our state in git stage and move on to the next step. The next thing I want to do is finally bringing this all together and having this import be used in the code we generate. And this might be a bit tricky, and at first it will require some handcrafting, but this has been our process all along, where we first make things work, try to a very specific case, and then figure out how we can abstract things away and make it nicer to use and in generally more useful. And I find it just being a good approach in general to programming rather than trying to plan out the universe, which may be something you want to do if you're trying to launch a spacecraft with humans on board, but if you're writing some hobby software, that might be not a very good idea. Okay, let's see. So this stuff basically can go away. We don't need it. Instead, I want to now focus on these things. And this is very interesting. So as I said in the beginning of the video, we need to change around how we deal with this stuff, because right now, when we call function .end, we immediately encode it, and it's not what we want for this to work. We can go about it two ways. One way would be to start generating this import directory as we sort of do the generation of code for functions, but it will cause problems if we have libraries imported in a not in a common place but spread between program, because imagine I imported something from kernel 32, and then the next function imports from user 32, and then the next function again imports from kernel. But if you already started to write out these two directories, we either need to do weird patching or move things around, and this is not what we want to be doing. So we will need to prepare the whole program and only then pass it to this function that we will do what it needs to do. And as I said, we will need to change all the tests and everything here to do the same for our JIT code to match this behavior. For now, I think I will not break the compatibility for the test, because it will be quite annoying to fix all of that, and I might do it off screen. So for now, I'll just add more things to here. And let's check what our encoding function actually wants to have, because eventually this is what we will be calling it with, and it wants the function builder. Why does it want the builder? It wants the builder because it uses it to figure out some stuff about So this is kind of interesting, and we might need to change a few things in order to make it work. Let me think for a second how we want to tackle this. So ideally what I want is, right now I kind of want to have code outside of the function almost, but we could show it in the function builder as well. But we will need to create one ourselves rather than relying on our macros. This is going to change though. So let's, this is still handy, so we can call function begin. Okay, let's do it this way. We need value star result is 0. We pass in a pointer to it, and then we pass in the program. Okay. Let's see if that builds. That does. Let's continue. We can, but it returns a builder, and this is what we need to store somewhere. It would be handy if we store it as with name underscore, because that's what our macro uses. So we do the same. We say builder underscore is this, and now we can use regular macro functions to deal with this stuff. The only thing we will not do is we will not call function end, and we will have to sort of split function end into multiple things. And this stuff around stack reservation and things is also going to be quite interesting to change, because now this shouldn't be really encode instruction, although no it is. Okay, I guess all of this is fine for our tests right now, because we will have the knowledge. Yeah, let's see how we deal with this. I guess for now what I will do is I will put a function builder star, and it will be entry point. So this is kind of like a main function in C. I'm not sure if that will be how it will work long term, but for today I just want to make our program that does 42 work, and this is all that I'm trying to achieve right now. Okay, that means that with program I can do something like this and say that entry point is builder. Apparently something did not work particularly well. This thing does not know what function builder is, which is fine. We can switch around these two, I think. Yep. We didn't know what the program is, so they point to each other, which is fine, I guess. I will just update this stuff. This is also something to fix, because they shouldn't be really pointing to each other, maybe, I don't know. We'll figure it out. So program.entry point is builder. Okay, we are still building, but nothing really changes at the moment. And now what I want to do is find where we do imports I think we have this stuff about DLL. Is it in this file or maybe it is in the other one? I'm not entirely certain. I do remember that we tried to import a function. Was it get std out or something? Yeah. Okay. And the reason I want this is because we have a way to specify a rep relative address for this. Yeah. That sounds good. I can copy a bunch of this stuff from here. And now you probably see how it all fits together, right? So we already have this support for DLLs, which does sort of exactly the same thing as we do in Executable. So when we will be JITing code, we'll have another function just called like execute JIT, and it will perform this stuff for us. It will still create this location in memory, and it will still do what we need it to do. Okay. So I want to replace this with exit process. Here I can do the same for now, but it doesn't really matter what I put here. I guess I can put 0. Is that fine? Yeah, that's fine. This C function value is another thing that we need to fix. So we'll need to create something like import function that only accepts these, but also accepts the name of the DLL that is going to be used for this. And this is exactly what it complains about, I guess. Okay, so address. Let me figure out how this works. So we reserve a global value, and that value is a pointer to something that we need to now rename to exit process value, which we can easily do. And it wants a value from S32. It will be 42. That's fine. We don't need this function wrapper, as I mentioned, because we are doing the function builder manually for now. But this stuff should be fine. Okay, that seems reasonable. What do we put in address? That is a very, very interesting question, because the way the arithmetic works right now, I believe, is that if you look at encoding and we look at rep relative, it just takes the difference between where we are and where we are supposed to be. So there is buffer memory, start address, buffer occupied. Okay, so next instruction makes sense, but operand immediate is, yeah, this is not exactly what we want for encoding executables, because let me explain what I mean. In here, right now we have 2 buffers, but as I mentioned at some point, these 2 buffers, we don't really control the memory, and that means that we don't know how far apart they are in memory, and while we're doing JIT, it was perfectly fine. In the encoding here, we would just take the difference, and that would be the rip relative address that we are using, but in an executable, we need to calculate this exact address based on the relative virtual addresses, not the actual addresses. And that means that this encoding routine will probably need to know a bit more things about our stuff, and we need to figure out how to do this. So one thing is definitely it will need to know, it will need to treat start address differently, and that should probably be enough. So if we make it accept a start address and also make this stuff to be relative to the R data section, then this could work, I guess. I don't know. This is going to be tricky. We will need maybe a different operand type for now or something like that, just to make this work slightly smoother at this particular instance. And maybe that's what I will do. So I will just create another branch here. And I will say that if operand type is what? If operand type is import, then what do we do? Well, we still do this stuff. Maybe it should be rip relative import. Yeah, something like that. Our start address is essentially 0, so we can remove this stuff. We just need to know what is the offset from our code section. And then whatever comes in here will need to be the relative virtual address of the pointer as we encoded it in stuff. So here, for now it will obviously fail, but here we say text section offset plus next instruction address. So this is our stuff, like our current address, and we can even call it that way. So let's just say s should be probably 32, but it will complain to us if we do that. So let's keep it as 64, and we say, oh, let's actually add it to here. So we say text section offset. Okay, next instruction. And import or IAT RVA is gonna be operand. I don't think that immediate 32 is a good name now, since we'll have a separate operand type for the moment. We can change this to be something like directly IAT RVA, and this would then make sense, I think. Yeah. Yes, these two things are very similar, and eventually we might be able to merge this, but for now I want to make progress, which means we need to do what? To add another operand type and say rip relative import. We also will need to make sure that we have this stuff here where we are matching the stuff. So something like this. Actually, I'm doing the wrong thing. Or maybe I'm not. No, I'm not. Okay, that's fine. Rip relative import memory. That would work. So it should find the instruction. Now we need to also change the operand itself type, and I also want to have S32 IIT RVA. Okay. Let's see what happens when I try to happen. Well, first of all, we can't print this, and that's okay. Relative import. Now that I'm thinking about it, the better thing to put into the operand would be so here we say rip import and we say %s, and inside operand, so it's a little error, but it's fine. Here we will put, let me grab these and move them up. We basically make our operand point to one of the entries in the functions array, and that way when we do the initial pass where we encode, like where we update their RVA locations, so this thing, where is it happening? It's happening here, yeah. So when we do this, we will update their RVAs, and since we now moved the encoding of the text segment to be the second part, it will be automatically updated. And then this loop is not going to be necessary. Instead, this, or it will be necessary, but it's going to happen at a different point in time. This will happen when you just kind of call the function. And even that is going to be easier to do. So I kind of like this approach. Did I put them in the right place? No, not yet. So now I say just import name to RVA star. Oh, now that I'm thinking about it, star is going to be a bit of an issue. So one of the problems with dynamic arrays is that you can't really take pointers to their items, because when array is resized, the pointer will become invalid. Instead, you would store index or something. This is slightly annoying, to say the least. How do we do this? Well, I guess we do it the slow way. And we just say we add one more of these. And we say operand rip relative import. We put it in here, and we put saying that it is an import. And what we put in here is two names. So we will have those loops after all, and we say library name and function name. This is going to be terribly inefficient, but it will allow us to make progress, and cleanup can happen at a separate stage. Okay, so this is fine. Now this thing does not understand what to do. So first let's put here, and we'll have say %s, and at least with our import, we can do it very easily and say library and function. Although technically it shouldn't be called function, it should be called symbol, because we can also import stuff that is not functions. It's called library name and function name. Guess let's do it the right way right away. So let's code symbol name. Library name and symbol name. What library name and symbol name. Good. One less error. Now the issue is this stuff. Okay. So builder actually has access to program, so we need to shove more information on the program. That's okay. We can, let's leave it here. It's fine. What we need to put on the program now is the text section offset. And for GDIT code, it will be basically this stuff, but for executable, it will be something else. And the way I do that is I say S32 code base. It's called an executable, so let's just call it the same thing. So this is easier to relate. Now I do inside encoding. This needs to be code base, and I say S32 code base is builder program code base. Program is not a member of function builder, is it not? I thought it was. We have program. It doesn't actually store the program, it just uses it for reference to the buffer. Well, what should we do? What should we do? I guess let's store the program for now. This is getting quite ugly, but it's fine. I say program star program. And inside of the function, where are you? Here. We will store it here. Say dot program is program. Okay, that did not work very well. What did I do wrong? Yeah. So they are pointing to each other, which is again never good, and also causes these kind of problems with C, because you need to declare it ahead. But we can do that. So that is solved. Now we have our code base, which is good. And now that I'm thinking about it, I could just pass this information right now directly and be happy about it. Whatever, doesn't matter. Let's keep as it is right now. So we have this stuff, but we don't know operand IAT-RVA, and we do need to know it. So let's say IAT-RVA, but we have just the code to get it, and it is this stuff. So we take these things and we slap it right into here. We can say that program star program is builder program, just so that it is, we don't have to change this code. And as far as the name, well, we have operand for that, so we can say operand import library name and operand import symbol name. Good. Now we don't need to patch it. Instead, this is our div. So like this. And let me think. Yeah. We basically move all of this stuff over here. And this is how we add it to the right place. So we say function id array. We don't need this stuff. And we are getting some progress. Let's get back to this. This is not rep relative, this is rep relative import. And it's also not value global anymore, I guess. But we'll see how we need to change this stuff. For now, I'm not sure. I will construct the value myself as well. And, or rather, I will change this exit process value. I know this is a pointer. No, this is fine. I'm not sure about value global though. So we will do global operand is operand, and then actually let's do it completely ourselves first. Value import value, and or it was exit process value, that's fine. This is not really right. This should be calling the import value, not the exit process value. So I guess it was doing the wrong thing there. Oopsie. Okay, that's fine, I guess. We change it to call the right thing. Okay, global operand. Instead, we are doing this, and we say that this is a descriptor. And here we will have operand, and type is going to be this stuff, and then dot import is going to be very straightforward. This is going to be our precious exit process. So symbol name is exit process, and library name is kernel 32 DLL. That seems good. Let's see what happens. Okay, I don't think I changed enough for anything to stop working. So ideally what happened is we pushed a bunch of instructions with this stuff, but we didn't actually use any of that, so it should be perfectly fine. Okay, let's try to run the test and see what's going on. Okay, that's not promising. Let's see why we have issues. Devenv mass Visual Studio. I believe it should be yeah, it's the function spec that crashes. So let's try to run this and see where we are crashing. Uh, the Yeah, it wants to call the function value, but instead we have a pointer to function. Yeah, we don't need this. Instead, we need to shove this operand. So it was actually correct. It should be exit process value. Operand is like so. And then we don't need this stuff, I guess. Yeah. Let's try again. Cool. So we are not breaking anything, and we are ready to proceed to the next step, which is actually trying to make all of this work. Now, over here, this needs to go away. And instead, we have to figure out how to yeah, essentially we need to call function end here instead of doing it in the previous place. So let me explain what I mean. We have this function builder, we do this call, but all it did, it just pushed the instructions into a buffer, which we then iterate through over here and encode each of the instructions. We can't trigger the function end over here because we don't yet have all the stuff for executable, namely we don't have these resolved to some location in the file. Instead we need to trigger it here. I think I will need to do some forward declaration, which is not very nice, but I'll just hack something in for now so that we can proceed with this. Okay, so we have function end that is doing the builder, and it also will need to put these somewhere. It will output it to the buffer. So we need to change builder buffer when we are in here. So we say that program entry point buffer is exe buffer, right? We want our encoding to be writing there instead of anywhere else. And now we can call function end of program entry point. Okay. That should do something. Whether it does what we want, it's a different topic. I doubt it will work, but let's try it out. Okay, so that's good. He did not find an acceptable encoding for move R64 rip import. That is strange. I thought I added this here. Yeah. I'm missing actually a type here. It should also support type register memory. Probably now we get into the point where we should clean this up, but not right now. It still didn't find acceptable encoding. That's not great. Why did it happen though? So on the left side we have R64, on the right side we should have one of these. So register memory. Not exactly sure what's happening. Let's try to run this here. I doubt it will give us much details on this, but let's still see. So this happens obviously in function end, but it doesn't give me much more information about the instruction itself. So yeah, it's a move. What is the operand stuff? One is the register A. I believe this happens before we do the call. So we move the address into register and then we call it, or maybe not. We'll figure out what it is. And then this one is import. So at least this part is fine. And I guess we need to find where this instruction comes from. And this is slightly unfortunate, as I said, because we don't really have a way to do that right now. I wanted to make a separate effort to make that happen, but I guess we're doing it right now. So, push instruction. Let's find what it is. It's probably somewhere at the very top of this file, or even not in this file at all. Yeah, push instruction. So what we're gonna do is we're gonna do push instruction internal, and then it will accept S32. It will accept const char star file name, and it will accept S32, or it can be E32, doesn't matter, line number. And essentially what's going to happen is we now turn the actual push instruction into a macro, and hopefully, if I'm not going to mess up something, we would be able to keep track where this instruction actually is done. Obviously, that will need for us to change the instruction to be able to store these two things. But for now, let's just say that it accepts a builder and an instruction. And what it will do is it will do push instruction internal, and it does builder, and it does instruction. We need to wrap each one of these into braces because otherwise it will not work. And I think it is this. I haven't done this in a long time, so I'm not sure if it's the right way. Let's try to build this. Did I miss some? Usually this happens when you have a missing brace somewhere or something like this. Where is it? Oh, yeah. This is a bit unfortunate. I guess what we're gonna do is we're gonna change around the so what is happening right now is we are passing an object. Let me explain this bit about C macros. when you pass an object into a function like macro, if you end up having commas usually, and those are treated as commons for the argument. So it treats like this is the first argument, this is the second argument, and this is the third, and so on, instead of treating this whole thing as one argument. You can fix this by adding another pair of braces on it, but in C99, I believe you could do the trick where you just put args into here, and no matter how many are split, it will still do the right thing. Obviously, that requires us to slightly change how we call this function to have it like so. Okay, at least that works, which is very encouraging. Now I want to say that instruction file name is file name, and instruction line number is line number. Obviously, we need to add these two to the instruction. So here, and I will shove it at the bottom because we use like unnamed fields when we push these for convenience. Let's see if that is better. Okay, that builds. The final touch is over here, or more precisely, maybe over here, where we print this instruction, right? So we have this error where we know what we cannot encode, and we now should be able to say from which place it actually came. And saying at here, say instruction, file name, and instruction line. In the future, we will extract this stuff into a more generic thing because we'll need to know location information for all this stuff that we are doing, but we are doing small steps at a time. It's %s colon % u, I guess, or what? Yeah, I think it's u. Let's see if I remember correct my printf modifiers. Let's try to run this again. Okay, so this is better. Now we added location information to our stuff, and we know exactly where this stuff is coming from. So this is happening at function C, line 115. Okay, line 115 is this thing, right? So this is very, very neat, and now we know what is happening. So yeah, essentially so what do we check here? If operand is immediate 64, yeah, if A is register, I'm not sure why I did it this way because it reads wrong. So if A is not a register, and it's not our case, or both of them are memory direct, it's not our case, yeah, so we end up here, and we are saying that there should be an encoding that is for this instruction, which is mov64 and then rm64. I guess I know what the issue is, and this is just me not doing the right thing, because we now have this check for byte sizes, right? And if the byte size doesn't match, the instruction doesn't match, and I should have done this. So let's try that again. Okay, well, we made some progress. Now it says operand type is operand type memory indirect at encoding at 195. Memory indirect. So it is this assertion, and this happens because we need to do it like this. Let's recheck where else we are doing this. So there is this import. Yeah, that's fine. That's fine. Fine. Okay, so this hopefully was the only place where we were doing the wrong thing. Let's try it again. Okay, well, we made some progress. More precisely, we did write something to the executable. Let's start scrutinizing whatever we wrote there. I want to look at it. Sections, text. Okay, well, that does look like some assembly to me, so this is encouraging, let's put it that way. The problem probably is in the addresses somewhere, but we can deal with that. It also might be better if we try to encode the assembly directly first to closer match what was happening before, but I'm not sure. Let's spend some time trying to make our automatic generation work. If that doesn't work, we fall back to literally encoding these instructions, right? This stuff, because we know exactly what we need to do. But yeah, let's try to first make our stuff work. And that means that we probably can try to run it in Visual Studio. Let's save this. And I say dev env build test exe. We do debug step into. Okay, let's try to figure this out. What do we have here? Go Visual Studio Update. I'll do it later. We have sub RSP, move to H. All of that is perfectly fine. It does use full on RCX, which shouldn't really matter. And instead of directly calling it this way, it sort of moves it into RAX and calls RAX. But the interesting part is this address, which probably isn't correct. Let me look at this. So these are 4 bytes that we have. And yeah, that can't be right. That's just is nonsense. And the reason this is nonsense is because we don't actually set code base to be the right thing before we do the encoding. So let's do that. Program code base is text section. What is your name? I can never remember the right names. I guess you called virtual address. Where are we? Virtual address. Yeah. So let's try that again. Build failed because this thing holds on to executable for whatever reason. No, don't save. And we can try that again. Okay, that's interesting. So we have a different error, and this is something we again can debug. I probably should have kept open this stuff, but it's fine. We can look at these things. Okay, what do we have? Well, I want to know what program code base is. Well, that looks fine. What is our function IIT This is 1000E. Well, that looks good. And I guess my stuff is wrong. Yeah, it definitely is. I was trying to be too fancy with hex stuff and that beat me. So what I want to say is, so this is on the negative side, I guess. How do I check this? For now, okay, let's just remove this check and try without it, but I need to carefully convert these numbers to make sure I'm doing it right, how it encodes the negative numbers. Let's rerun the tests. Okay. And I still want to look at those numbers. So that's F10. Let's look at these things again. We have next instruction address. Okay, that looks a bit... Oh yeah, that's just wrong. That's just really, really wrong. It shouldn't be buffer occupied here. What do we need to put in here? That's a bit tricky. We will have to pass in another parameter to encoding that will be So the issue is that it needs to have code base RVA, and it also needs to have code base file address. And here we need to div those two. Program, let's align it like this. So program code base RVA, program code base file offset. Let's put it in here. Base RVA and code base file offset. We just need to fix a couple of issues here. Code base is super easy. We already have that, so this is code base RVA, and this is going to be code base file offset is this stuff. Okay, let's try that again. Start. Let's look at what we have now. Next instruction address, that looks way better. So I can believe that we are at the 12th byte in the program. So that looks good. Let's continue. It can't write out the file. That's okay. That's all good. Let's try to. And look at that. We have 42. That's really, really awesome. Yeah, so that means that we can now import stuff and we can call it, and we don't have to have any hard-coded things. Now, we should actually keep this stuff here. This is a nice thing to do. Ideally, all functions should come with int3 at the end. So well, let's just do the right thing right away, even though it's a bit of a distraction. But so the reason we want to have int3 at the very end is because you if by some accident you skipped past the end of the function, you should trap. But I'm not sure if we have this encoding, so for now I'll just say fix me add encoding. Okay, great. Let's watch again our test class and have this glorious 42. And now, since this is dynamic stuff, we can also do 1, 2, 3. And we build again and we test and we have 1, 2, 3. Great. I'm really, really happy with the progress we made. We also made a bunch of mess along the way, so I will either make a cleanup video or do it off screen. I'm not sure what I will decide. But on this high note, I say it's time to wrap up. Thank you very much for watching, and hopefully see you next time.